now operators in Python. So we have this following operators. We have which we are doing. We do it with the help of operators. Let's quickly see all those operators. So we have arithmetic operators that are the basic mathematical operations. We have plus, we have minus, we use this asterisk for multiplication, we use the slash for division, then we use this percentage operator for getting the modulus. Now the difference between this single slash and double slash is that this slash performs the actual division operation. For example, if I say 5 divided by 2, so this slash will give the output of 2.5. But if I give this double slash, so what it will do is it will give the integer output. For example, if I say 5 divided by 2, this will give 2.5, but this will convert it into integer, and then we get to, as you can see, it is mentioned, it is floor division. So the the nearest integer which is lower than the actual value. So the nearest integer which is lower than the actual value, for example 2.5, it is 2, so we get that output. Now double asterisk, it is used to perform the power operation. For example, if I say 7 asterisk asterisk 3, so that will basically result into 7 raised to 3, and we get the resulting output. Then we also have these comparison operators. We have this greater than, less than, double equal to, basically checks for equality if both sides of this particular operator are equal or not. If they are equal, it will return true, else it will return false. So all these comparison operators return a boolean, that is either true or false. Even greater than, less than, double equal to. This is a not equals to sign that will give us the result if both sides of the operator are not equal, it will return true. If they are equal, it will return false. Then we also have understandable. So now we also have logical operators. You might have seen this in your mathematical logic chapter. So we have the gates and mathematical logic, and gate, or gate and not gate. So they sort of perform the same task as we have seen in mathematics. So and operator is check if both both the statements, or both the operands are true. So in that case, it will return true, else it will return false. In or, if either of the statements are true, it will return true. If both the statements are incorrect, that will return false. So we make use of these comparison operators and logical operators in one single statement. Let me quickly demonstrate that as well. So here, now if I say x equal to 5 and I say y equal to 2. Okay, so this is true, and y is less than 3. So this is true, so it will give true. Now, for example, if I say x is less than 3 and y is less than 3, so x is less than 3, that particular statement is false, but this is true. But and gives false if both the outputs are, if either of the statements are false. So over here, we'll get false. So if talking about the OR operator, if either of the statements are true, it will give the output as true. So taking the same statement, but since one of these statement is one of the sides of the OR operator is
Umang,
true,
you can
so
zoom a
that will
bit.
give the output. Yeah, just a second.
Control plus or control scroll up.
Yeah, I'm doing.
No problem. You can continue. Don't. Continue. Continue.
Yeah, just a second. Mm, Okay, so yeah, so this is one particular statement where the left hand side of the OR operator is false, but the right hand side is true, but we get the result as true. Now, if both of the statements are false, for example, this is false, and even this is false. So y is greater than 3, that is false. Also, x is less than 3, that is also false. So we are using the OR operator, and both the statements are false. So we get the output as false. So this is the working of and and OR operators. We also have the NOT operator that changes the truth value of a particular statement. For example, if I say x is greater than 3, this is true. But if I say not of x greater than, oh, sorry, x is greater than 3, see, over here we get false because x greater than 3 is true. But since we have this not prepended over here, so we get false. So this is how bitwise operators works. So in Python statements. So yeah, so then we also have bitwise operators. Now bitwise operators, they perform operations on the individual bits. Now, as I said before, that every data, every variable, or every value is stored inside your memory in the form of binaries. So for example, if you want to perform operations in binary, so make use of the bitwise operators. So these are some of the binary values. 2 is 010 in binary, 7 is 111. You can find various videos on YouTube on the this binary numbers. So you can definitely have a look over that so that you can understand all these operators very well. So we have bitwise and operators. Before, over here we have seen logical and. Now we are seeing bitwise and. So it will actually and all these numbers, like anding x, for example, it is 2, so it will get converted into 010 in binary, and 7 is 111. So if I say 010 bitwise and, that is if I say 2 bitwise and 7, so it will perform and operations between 010 and 111. So the first bit 0 over here, 1 over here. 0 and 1 will give 0. 1 and 1 will give 1. 0 and 1 will give 0. So we again 2 and 7 will give the output as 0 1 0. So that is again 2. So this is how bitwise and operator works. Similarly, we have bitwise OR operator, which performs OR operations between two numbers. Then we have bitwise exclusive OR, which is also one kind of logical operator, which you might have seen in mathematical logic, but that can also be used to operate on bits. Then we have the right shift, and we also have the left shift. Right shift is basically it shifts the bit. For example, if I have 0 1 0, so that will shift the bits and prepend 0. For example, if I have 2 and I right shift this particular thing, so the result will be 0 0 1. So this is how right shift occurs. Similarly, we have the left shift operators, which shift the bit values to its left. Then we have assignment operators. We have already seen one of the assignment operators, that was the equals to, when we used to assign values to variables. So we used to say like x equal to synergy. So the synergy value was assigned to that x variable. So let's have a look at some more assignment operators. We have equal to. What this basically does is x, for example, if I have this x equal to 5, so that will shift the bit value to its left. Then we also have plus equal to, which is equivalent to, for example, if I have x plus equal to 5, so this is equivalent to x equal to x plus 5. Similarly, we have minus equal to, which will take this, and this is equivalent to x equal to x minus 5. So the current value of x plus or minus, according to the operator which you're using, this particular value. So yeah, so we have plus equal to, we have minus equal to, we have multiply and equal to, we have divide and equal to, we have modulus and equal to, integer division and equal to, power and equal to, so on and so forth. We have all. We can also club bitwise operators as well with this equal to sign. So we can basically shorten our Python statement using these assignment operators. Then we have some special identity operators. So for example, if I have in this identity operators type, we have is and is not. So what we do is, for example, if we have a list which no, sorry, not really, just a second. So sorry, so that is in and not in. So these are used to check if two values are located on the same part of the memory. So if they are located at the same part of the memory, and if I check the equal, now you can say that this is sort of equal to the same as the equal to sign. That is the logical operator which we have seen. but that is sort of different. So if we make use of the equal to sign, it will just check that if both the variables hold the same value. But in case of is, it will see if they both are a part of the same address. Now we can have two variables, and if we use of is operator, that will lead to false. But if we make use of the equal to operator, that will result in true because the values are same, but the location where those variables are stored is different. I can make use of Python IBM. So if I say so as is, it takes if I have x equal to 5 and y equal to 5. So that those particular these two variables will not be stored on different locations inside your memory. So 5 will be 5 will be stored in one block of memory, and x and y, these variables will point to that particular value. So if I say x is y, this is true. Why? Because the locations of x and y are same. Coming from different languages, you might think that the x and y will be stored in different locations, but no, that is not true with Python. In Python, if the value is same, they will be stored in the same locations. Now, even x equal to 5 will produce the same output. That is true. But this will create a difference when we will make use of some structure which even though can hold the same value, but they might be stored in different locations. We'll see all those things, all those complications in our next session. But for now, just understand this: the is identity operator is basically used to check if both the variables are located in the same location. Its counterpart is not is used to check the opposite thing, that if x1 is not y1, that is if both the variables have some different location inside the memory, is not will return true, and if they have the same location, is not will return false. So then we also have membership operators, which I was quite jumbling up before. So we have in and not in. So if I have a list, for example, say which have values 1, 2, and 3, and it is somewhere in the program, I don't exactly know the values which are present in the list. And so if I check in, it will return true if 2 is present in the list. And if it is not present in the list, it would return false. So again, yeah. So I have this list, yes, which contains a 1, 2, and 3. Now if I say 2 in list, this will return true. And if I, for example, say phi in list, so this will return false because phi is not present inside the list, but 2 is present, so it will return true. In the same way, we have the not in. So if 2 not in list, so this will return false. Why? Because 2 is present in the list. 2 is in the list. So not in list is a false. So we get false. So, and then if I say 5 not in list, so it will return true because 5 is actually not inside the list. So this is what we get. Yeah, so these are some of the membership operators, that is in and not in, that are used to check whether a value or a variable is found in sequence. For example, list, strings, tuples, set, dictionary. We can use the same thing for strings as well. So suppose we want to see if a particular character or a particular group of characters are present in the string. We again make use of this in membership operator. Same thing can be done for tuples, sets, and dictionary. But in case of dictionary, we can only test for the presence of keys. So for example, if you have name as your name and class as your class, so if you want to check I'll demonstrate that. So if I have this dictionary where sorry, I didn't get you. Yeah, okay. So if I have this name, for example, the name is Synergy, and then I have, for example, the year year is, for example, 2. So this is my dictionary, and now Oh, sorry, just made this mistake. We make use of colon and not the equals to. So I think the name is synergy, and then we have year as 2. So this is our dictionary. So now if we want to check for, if we cannot really check that if synergy is present in the dictionary, so that will lead to an error. Let's demonstrate that thing. If synergy in D, so that is a false. Okay, so but if I see that if this particular key is present in the dictionary, so that is true. So we can check for keys, but we cannot check for the values. So this is one thing which we have to keep in mind in case of dictionaries. Okay, so moving on. Yeah, so this is again one example of a membership operators. We have suppose this string x equal to hello world. So if we can check if h is in x, so h in x, yes it is. So it will give the output true. Now we have this dictionary y, one is a and two is b. So if we can see over here, if one in y, so one in y, yes, the key one is present in the dictionary, so that will again give true. Now look at this particular statement. Since we have mentioned before that Python is case sensitive, so this H hello and this hello with a capital H, they both are different. So if I check for hello in X, that will give false. But since over here we have hello not in X, hello with the small h, so that will give true because this hello is not present in this particular string. In the same way as I explained over here now, that we cannot check for values inside this particular dictionary. So if we check for some particular value, for example, over here a in y, a is a value that is not a key, so that will lead to false.